Connie Crete, a brilliant young engineer, stared at the cracked concrete cylinder on her lab bench. It was supposed to be ultra-strong, a testament to her skills. Instead, it looked like a sad, gray biscuit. "It's just not working," she sighed. From across the lab, the wise Professor Sylvan smiled gently. "Perhaps you are missing the secret ingredient," he said, his eyes twinkling. "The secret?" Professor Sylvan began, holding up a small jar of fine, silvery gray powder. "Is silica fume." Connie frowned. "Silica? Like sand?" The professor chuckled. "Not quite. This powder is born in the intense 2,000 degrees Celsius heat of an electric arc furnace. It's the captured vapor, a silver spark from the process of making silicon metal. It's less like sand and more like condensed smoke." Connie peered closer. The powder was incredibly fine. "So the key to stronger buildings comes from making computer chips?" Professor Sylvan nodded. "In a way, yes. Each particle is a perfect, tiny sphere, 100 times smaller than a single grain of cement. Their size is the first key to their power. Before any chemistry happens, it's a master of geometry," the professor explained, sketching on a whiteboard. He drew large circles representing cement, then filled the gaps with tiny dots. These ultrafine spheres pack into the voids between the cement grains. This particle packing makes the concrete physically denser before it even begins to harden. There is no wasted space. "But its real magic is chemical," he added, drawing another diagram. "When cement hydrates, it creates the strong glue we need, but it also produces a weak byproduct, calcium hydroxide. Silica fume is highly reactive. It hunts down that weak material and transforms it into more of the strong, cement-like glue. It turns the weakest link into more strength. This has a profound effect on the weakest part of any concrete, the transition zone right next to the stones," the professor continued. "By making that zone so strong and dense, a crack in the concrete is more likely to break right through a solid piece of granite than to go around it. That's true strength. But this incredible power comes with a great responsibility," Professor Sylvan said, his tone becoming serious. "Because the particles hold water so tightly, the concrete doesn't bleed, water doesn't rise to the surface. This means the surface can dry out and crack in minutes if it's exposed to sun or wind. It's a race against evaporation." Connie was stunned. "So all this strength can be lost in a few minutes?" "It can," the professor replied. "That's why it demands discipline. You must protect the surface immediately. We use fog misters and special compounds the moment the finishing is done. The lab gives us the recipe for strength, but the real world demands we protect it. To truly appreciate its value, consider this," the professor said, pointing to a picture of a large bridge over the ocean. "That bridge deck is constantly attacked by salt from the sea spray. It survives because silica fume makes the concrete so impermeable, so waterproof, that the corrosive chlorides can't get in to rust the steel reinforcement. It is the key to durability." Connie looked back at her broken cylinder, but now she saw it differently. It wasn't just a failure, it was a puzzle. She understood that the silvery powder in the jar was a microscopic marvel. The concrete all around her wasn't just stone. It was a testament to a hidden science, where captured smoke could be the foundation of a bridge that lasts a century. She couldn't wait to mix her next batch.